this video, we try to prove the equivalence of a given relation. You may read this question. If you wish to do it yourself, pause the video, do the question, and then you can watch the video and see if you have done it correctly. I start with the given set. The given set is n cross n. So the given set is n cross n means it's a Cartesian product. So every single element I pick up from this set is going to be an ordered pair. That's why when you see the relation, it says a comma b is related to c comma d implies ad into b plus c. So I picked up two elements from n cross n. A comma b is one element and c comma d is another element. And we say a comma b is related to c comma d if ad into b plus c is equal to bc into a plus d. But I think I always find that this is going to be very confusing if you just try to follow just the letters. You should be able to say this relation in words. Now, how do I convert this into words? When I look at this AD, I realize that it is the product of the first term with the last term multiplied with b plus c, which is the middle terms. So it is product of the extreme terms a into d multiplied with sum of the means, which is b plus c. So I have product of the extremes into sum of the means is equal to, when you go to the other side, it is product of the means b into c multiplied with sum of the extremes. So you should be able to say this in words one more time. So how do I write this relation? I say a comma b is related to c comma d if product of the extremes into sum of the means b plus c is equal to product of the means bc into sum of the extremes a plus d. So that's the relation we have. Now we are going to try and prove that this relation is an equivalence relation. To prove that it is an equivalence relation, I need to prove three things. The first property is that it has to be reflexive. And to prove reflexive, I need just one element taken from the given cross product, given set. So I say for every a comma b taken from n cross n, I picked up one element from n cross n. I should prove that every element of the given set n cross n is related to itself, which means now I should say that a comma b is related to a comma b itself. Every element is related to itself. That's when we say it is reflexive. So I'm going to make that statement. I will say a comma b is related to a comma b. And I justify it this way. I try to apply the rule. What's the rule? Product of the extremes a into b, so I wrote that here, multiplied with sum of the means, which is b plus a, the mean terms, the middle terms. So ab into b plus a is equal to, now the other way around, product of the means, middle terms, ba into sum of the extremes a plus b, which is here. And when I look at that, I realize that BA is nothing but AB itself, and A plus B is same as B plus A. So I have both the same. So I have justified the fact that A plus B is related to A plus B. So if every element A comma B of n cross n is related to itself, A comma B is related to A comma B, we say the relation R is reflexive. So we proved reflexivity. The second property which I need to prove is that it is symmetric, and for symmetry I need two elements. So I'm going to pick up two elements now. I take an a comma b and then another c comma d from the given set n cross n. So if you have two elements, I'm going to first assume one relation here. I'm going to say that a comma b is related to c comma d. So if a comma b is related to c comma d, I should be able to prove that c comma d is then related to a comma b. That is the symmetry property. So I'm assuming one of it. I'm just saying that a comma b is related to c comma d. When I proceed with that, I should be able to prove it the other way around. C comma d is related to a comma b. Now, what does this mean? A comma B related to C comma D. Product of the extremes, which is AD, into sum of the means B plus C is equal to product of the means BC into sum of the extremes A plus D. So this is what we know. But out from here, I need to prove that C comma D is related to A comma B. So what I do for that is I write this the other way around. From the other end, backward I write. So if you look at this, this is BC, I'm writing it as CB. Then this is A plus D, I write it as D plus A. When I go to the left side, AD, I write it as DA, and B plus C, I write it as C plus B. Basically, instead of reading it from left to right, I read it from right to left. I just write it that way. And this is exactly what we are looking for. We just write what we are looking for. We are looking for C comma D related to A comma B. So, since it is come the other way around, it is symmetric. So, R is now symmetric. Next is transitivity. And for transitivity, I need 3 elements. So, I pick up 3 elements there, all of them taken from n cross n. And I assume 2 different relations. I'm going to say A comma B is related to C comma D, and C comma D is then related to E comma F. Now, for each of them, I write the relation. What does that mean? Product of the extremes. So, I take product of the extremes, A into D into B plus C is equal to B into C into sum of the extremes A plus D. And I do the same thing with the other one. Product of the extremes, C into F multiplied with sum of the means, DE is equal to product of the means, which is DE multiplied with sum of the extremes, C plus F. And what I need to do is from here, I need to eliminate C and D. To eliminate C and D, I try to get C and D together on one side. So I open the bracket. I try to do this kind of a rearrangement. B plus C divided by BC. The similar kind of terms are put together. A plus D divided by AD. Same thing I repeat here. And then I divide them separately. When I divide them separately, B by BC gives me 1 by C. C by BC gives me 1 by B. A by AD gives me 1 by D. D by AD gives me 1 by A. And you can see that I did the same thing with the other one, divided separately. Now try to put C and D together on one side. So I bring 1 by D to the left side and take 1 by B to the other side. So I have C and D together on one side. And I do the same thing with the other one as well. And when I do that, here 1 by E minus 1 by F is equal to 1 by C minus 1 by D. So you have got 1 by C minus 1 by D here also, 1 by C minus 1 by D here also. So the other two are supposed to be same. So I equate them. So when I equate it, I get it this way, but I wanted all addition, so I rearrange the sides. So I get it this way. I rearrange. I make them into addition. Now I take LCM on both the sides. So AF is the LCM on the left hand side. I cross multiply both the ways. So F plus A by AF. Here the LCM is BE, and I cross multiply. So B plus E by BE. And then I cross multiply it again. So I get BE going to the left side and AF going to the right side. And if you look at this, this is what I'm looking for. I wanted AB directly related to EF. So I'm going to write that and check if it is correct. So I write A comma B is now related to E comma F. How do we know it is right? We check it. Product of the extremes AF into sum of the means B plus C, which is my right hand side, is equal to product of the means BE into sum of the extremes A plus F, which is the LHS. So that makes it transitive, and therefore R is an equivalence relation.